Hello, and welcome to episode 196 of The Joy of Coding. How's it going? My name is Mike Conley. So happy to have you here. I hope your day is going well. Let's get started. Sorry I'm a little late getting started. Whoop, there we go. I'm a little late getting started, and the YouTube stream, once again, is not working. I apologize for that. Hang on a second. No. Afraid not. The stream key is correct. I'm attempting to debug the YouTube streaming issue, but for now the YouTube stream is down. So I apologize if that's the way you normally access the stream and you're watching this on Twitch or Mozilla, but welcome regardless. How's it going? Let's get started. So today is November 6th, 2019. It's episode 196, and as a general reminder, no plan survives breakfast. Kind of like the YouTube stream thing. Not everything's going to go right. Things can go wrong. Things can break. None of the stream is super pre-planned beyond the fact that I know that I have certain things that I want to do. But things can go wrong. I might get stuck. We might fix things, or we might break things. Who knows what'll happen. I might get distracted. I'm capturing real software development in the raw. So whatever happens, happens. So just a little FYI there. The second thing is that the agenda that we're looking at is something you have access to. If you're watching this on Mozilla, check out the handouts section over here for a link to the agenda. If you're watching this on, if you're watching the recording of this on YouTube, it's in the video description down below. And if you're watching this on Twitch, allow me to drop the link into the Twitch chat right now. Boom, boom, and Twitch chat, here you go. There's the agenda. There is an episode guide. It's completely viewer-driven, like by viewers like you. If there are episodes that you want to go back and refer to, there is a guide that will tell you everything that happened in a particular episode, or at least give you a sense of what happened. And we've got all the way up into the episode before last. I actually believe that there is episode 195 waiting for me to review and approve, so maybe we can just do that right now. But if you yourself have your own notes or addenda or corrections or who knows, helpful things that you want to add to the episode guide, send it my way. Send me a pull request, because the episode guide is for you, my viewers. So here is episode 195. I'm going to take a look at the pull request that came in. 195, October 30th. That's right. That's what day it was. And as normal, I'm just going to double check that the links are correct here for the episode itself. Yep, that's episode 195. And then the agenda, make sure that that is pointing to the right agenda. Episode 195. Gonna wait for that to load. Come on, Evernote. Is Evernote down? Okay, there we go. Episode 195. Yep, that looks right. And then the topics. So yes, that looks right. Yeah, this is what we did. Yep, nailed it. And I'll double check that the form is correct, but it looks like SmurfD once again nailed the agenda. So I'm going to go ahead and approve this. So thank you very much, SmurfD. And like that, the new episode is in. I also want to point out that Danny Colin, if I didn't mention this last week, I'll mention it now. Danny Colin provided some older episodes, missing episode 32, and there was another missing episode, maybe it was just episode 32. I thought there was another commit. Oh, and then there was a correction to 31, which was mislabeled as 32. So there you go, the episode guide becoming healthier and more vibrant because of viewers just like you. And if you want to contribute and you're not sure what a pull request is or how to send one, there is a contributing guide and links here in the agenda on what a pull request is, where the repository is, and how you can help contribute to the episode guide. So give those a read, and if you have questions, drop into IRC or the Twitch chat, and you can talk to me directly. I am in live hacking on IRC for now, and there's also the Twitch chat, which I'm paying some attention to. So what do I want to work on today? Well, there are a couple things that I want to do. I actually want to reorder this a little bit. I have a patch in flight for this bug that I have some review feedback that I want to apply and push up for re-review. Here's a new bug I want to get started on, and then I have some things in my review queue to look at, some patches from other people, and I figured that's gonna fulfill That's going to fill the hour, certainly, those three things. And if it doesn't, well, I'll find more things to do. There's always plenty to do. So what is this bug? This bug that I've been working on is an issue with some of the picture-in-picture code where we use this thing called a concept called a weak reference, which if you're familiar with sort of memory-managed languages like C or C++, you might be familiar with a weak reference, where the reference that you're holding doesn't impact the lifetime of the item. Like, we use reference counting in our C++ code so that the number of references, if they're greater than 0, keep what they're pointing at alive, and as those references go out of scope and destroy themselves, then once that count reaches 0, the ref count reaches 0, then the item that they're pointing to is destroyed. And that's one of the ways that we avoid memory leaks. And it's not perfect. You can get cycles, so we had to like build a cycle collector to find cycles so that we can break them and then reclaim memory. And but there is something. Sometimes you want to have what's called a weak reference to something, where instead of having a reference that increments the reference count, you have a reference that doesn't increment the reference count, but you want to do it safely, because if you're not doing it safely, then if other reference counts, if the reference count to the thing that you're pointing at goes to 0 and your weak reference is still pointing at it, then you're now pointing at memory that's been deallocated, freed memory, which that's a very bad idea from a security point of view and a stability point of view. So we have this interface called weak reference, which allows us to have a weak reference to an item and call a method on it, not on the item itself, but on the interface. It kind of wraps, the weak reference wraps the item, and you can call .get on the weak reference. And if .get returns something, then we still have a reference to the item. And if .get returns null, that means that all of the references were 0. And that way, and so you don't ever get like uninitialized or deallocated memory. What you get is either null or the thing that you wanted. Great. Well, one of the problems is that sometimes when you call .get on the weak reference, it throws this like really obscure XPCOM error. There's an old open bug about that, and the way that I'm working around that right now, because there are weak references that we use for picture-in-picture. We have a weak reference to the video. We have a weak reference to the picture-in-picture player window. And the reason why you want to have weak references is because sometimes you want to make sure that those references aren't going to be the thing that keeps those elements alive. You don't want to be responsible for a leak. You don't want to be responsible for keeping a whole bunch of stuff around that you don't need anymore. They don't own the item. This is a general problem in C++ or memory managed languages where ownership is unclear. Who is responsible for destroying a thing? And in C++, unless you're very, very disciplined about it, it's super unclear. It's really like, well, the last reference that goes away is responsible for cleaning it up, I guess, is kind of how it goes. In languages like Rust, I think the ownership is much clearer on who owns what and who is responsible for destroying what. But because JavaScript XPCOM is communicating with our native layer, which is mostly written in C++, we have a similar issue where it's unclear who the owner for certain things are, and so you can, if you're not careful, you can hold a reference to something and not let it go, and then you're leaking memory effectively. So that's why one would want a weak reference. And I've been dealing with these weak references, throwing this exception by wrapping them in try catch. But now that I think about it, I should probably instead of doing like a general try catch, I should probably do a check to see what kind of error it is upon reflection. Anyways, I've got some review feedback on this patch, and I want to try and apply it. So let me tour you through the patch as it's written, and then we can talk about it a little bit on how we want to proceed. So this is in a file called picture-in-picture child, which if you've been watching the stream for a little while, or the past couple of episodes, you might be familiar with. It's the thing that runs inside of the content process where either we are in the same document as a video that we want to open in picture-in-picture, or it's running inside of the frame where we're displaying the cloned video stream in the always on top window. And what I was doing here was adding a special getter called week over video that will return either null or the actual value, which is what a week reference is supposed to do. But this one handles the week reference error, the NS error XPC bad convert native exception, or it's supposed to anyways. So this is a good point. I've got this like state variable that really doesn't need to be around. I could probably find a way of one-lining that, so I can do that. And this ended up simplifying a bunch of places where we do that check of like, do you have the week over video, and can I call .get on it if there's a thing there, and if not, return immediately or something. There was another review comment. Where was it? Over here. Mark says, somewhat unrelated, but should these instead be calling methods on the picture-in-picture object like the other handlers? Maybe. That's a good point, Mark, and I can file a bug about that. That makes a lot of sense. Instead of calling into the player window directly, make the picture-in-picture object the one that calls into the window. Then he's got this piece of review feedback. Perhaps these helpers should be functions, so it's obvious you should store a reference. Get weak pip player or even get pip player, although the weak part might make it clear that this could return null. Perhaps these helpers should be functions, so it's obvious you should store a reference. Oh, I understand what he's saying. So that like you're not checking it and then using it. Like we're intentionally storing a reference here to the weak result here in this variable called player, and then instead of like using like if picture-in-picture.weakPipPlayer, then do picture-in-picture.weakPipPlayer.set is playing state true. I agree with him. I think that's a good call. And then he says, should the contents of the try be reduced here? Seems unlikely. Player win got closed. Should throw, but that isn't what the try is for. Yeah, that's a good point. I'm gonna beef this up a little bit. This is great review feedback from Mark. So the first thing I'm gonna do is I'm gonna file a bug for the issue he brought up. Where was it? In picture-in-picture.jsm here. So this is just an architecture thing that he pointed out, and I think it's worth doing. So I'm going to file a new bug, toolkit, video, audio controls. I'm going to say make sure picture-in-picture object is the only object that interacts with the player window directly. This is more, to keep a clear separation of concerns and responsibility. Oh, here, hang on. Before inside of picture-in-picture.jsm, we have two classes, picture-in-picture parent and picture-in-picture toggle parent. And I'm pretty sure it's just, which one is this? Picture-in-picture parent. What does picture-in-picture toggle parent do? Picture-in-picture toggle parent. Yeah. So we have a class, picture-in-picture parent, that directly accesses the player window via the picture-in-picture global here. All right, and then let's link to the source so that in the future people know what we were talking about. Here. permalink, copy here, and here's another one. Here and here. To keep a clear separation of concerns and responsibility, I suspect it's better architecture to expose some methods on picture-in-picture to do things like setting the muted or playing state on the like what are the set muted state, playing state, yeah. Pause, playing, pause, muting, unmuting. To set the muted or playing state on the player window and have picture-in-picture be responsible for actually calling into the window to set the state. Originally suggested by Mark Streamer, and then I will link to his review comment, which was here. And then for this, I can also go ahead and mark that as a task, say that show the advanced fields. I know that this is priority 3. I'm going to make it block the video pip metabug and submit. Then I'll also add Mark as CC on the bug. Good idea, and I'll respond here. Good idea. Filed this bug. Done. So can do that maybe in a follow-up later. Next up, making those functions instead of getters. I think that's a good idea. And then there was the other thing I wanted to do, which was to, instead of just like try catch, is to like explicitly catch this error value, and well, in any case, actually maybe it's okay. Maybe no matter what, we want to return null. Maybe that makes sense. No matter what, things have gone wrong, return null. That does make sense. Okay, let's deal with this next. So do I have this patch checked out? I think I do. Let me pump up the font so you can see. Yes. All right, picture-in-picture child. Oopsie daisy. Picture-in-picture child. So where's the line? It's 134. Yeah, so instead of doing let state equals this and then get state weak over video, what we can do is like let weak ref weak over video. I think we can do this. Actually, it's probably clearer to do it this way. Weak over video equals this dot doc state, and then Don't need state anymore. And then we're going to turn this into a function. Get week over video. Get week over video ref. Or maybe just get week over video. Return, what's the return value? Return, what's the format here? Return element. Or null. The video element that the user was last hovering, or null if there was no such video or the video no longer exists. So before this was this dot week over video. Now it's going to be get week over video, and it's a function. So let's see here. This dot get week over video. This dot video equals, yeah, this dot. I should probably just do find and replace, to be honest. Find, replace. This dot get week over video. Find, replace, 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 replace. And that's all of them. I think that's a solid bit of advice there from Mark. I really like that. Okay, so that's done. There was another, I mean, he originally had that comment for having those be functions inside of the picture-in-picture.jsm file, but I think it makes sense for picture-in-picture child as well. Picture-in-picture.jsm. And so instead of weak pip player, we'll call it get weak pip player. Return DOM window of the player window if it still exists and has not been closed and is not in the process of being closed. Null, or was this or null, returns null otherwise. The other thing was, yeah, the dot closed. So let player win. That. And now we have to change all the callers. This dot weak pip, weak pip player, not that one, these ones. We're going to change both of these to, what was it called? Get weak pip player? Yeah, get weak pip player. You know what? I'm gonna have to rebase as well because we're missing the muted and unmuted state patch that recently landed. Yeah, pro tip: if you are testing picture-in-picture, there's a thing that you might want to be interested in testing, which is this hidden pref called picture-in-picture Audio toggle enabled. Let me put that in the agenda. Testing that. So this adds a new capability to the player window, giving you the ability to mute videos. So I'll give you an example. I have mine flipped to false right now. I'm going to flip that to true. And then let's bring up this video.
Watch carefully.
Now here's Gordon Ramsay. But look, I've got these 3 buttons now, and I can mute Gordon Ramsay. You're muted now, Gordon Ramsay. And I can unmute him. I bleeped him just in time. So yeah, that's a thing that relatively recent landing, and I'm realizing now that I have to rebase on top of the patch that landed it. Also, there's a linting error on line 119. Oh, whoops. Yeah, shadowing. So I'm going to rebase, then I'm going to do an artifact build, because that should be a heck of a lot faster than doing a normal build. Pull. Oh, whoops. Someone was just talking about this somewhere. Okay, so the rebase is done. Let's take a look. Yeah, I've got to update here as well. Thankfully, that's pretty much a drop-in. Pretty sure there's nothing else that was using weak player. Weak pip. Yep. And then in picture-in-picture child, I'm pretty sure that there was nothing else that was. Oh, we're using this weak video. Weak video. Oh, should do the same thing, yeah. Turn these into functions. Probably. Okay. Get weak video and returns a reference to the video element being displayed in picture mode or null if that video no longer exists. Display in picture mode. Actually, return element, the video being displayed in picture mode or null if that video no longer exists. Okay, and then all of this weak video should probably replace Meanwhile, while I'm doing this, I'm gonna do an artifact build. Build with artifact. So that's gonna be done soon. And I'm gonna find, replace this .weak video. We're gonna replace it with this .get weak video. So replace here I'm gonna say let video equal this .get weak video if video on track video originating video get weak video. Another place, let video equal this get weak video if video whoa, what are we doing here? It's like, well, yeah, we're using all three. So video dot stop cloning individually. Cool. That video equal get weak video. Target equals start get weak video. And this if volume change, let video equal this dot get weak video. If video and video dot muted. If not video. Well, in this case, the video should be the target. If video not equal event dot target return. Video dot muted, so muting. Just double checking here. What does console dot assert do? Because maybe that's what we want to use there. Console dot assert. Assertion failed. Does it throw? Pretty sure it does. Console dot assert false. Console dot log. Here. Oh no, it just does both. Okay. It's okay, your Oopsie is not caught on the internet. Works on Linux. Tested with Twitch. Also works with tab mute. What Oopsie? What Oopsie that was on? Oh, maybe. Never mind. Works on Linux, tested with Twitch. It also works with tab mute on mute, as in it doesn't override that setting. When refreshing, Firefox showed this error, though, JavaScript error, invalid state error. An attempt was made to use an object that is not or is no longer usable on line 92. Let's take a quick peek. I'm looking at it on SearchFox because the line numbers have probably changed. Line 92. I wonder, in the event that we've destroyed getting the doc state remove. Mouse button listeners. I wonder if we should also stop tracking mouse over videos. if we're just being destroyed. That might actually solve that problem. Stop tracking mouse over videos instead of, because there's probably like oh, apparently I said oopsie for something. I'll have to rewatch the tape. Yeah, I wonder if we should be stopping observing here instead, or like stopping the tracking the mouse over videos instead of removing the mouse button listeners. So we like remove all of the event listeners. And we disarm all of the remaining like deferred tasks. That might be a good idea. Let me take a to-do. Consider calling stop tracking mouse over videos, stop tracking mouse over videos, and will destroy in picture and picture child. That seems like a good idea. Where was I? This.weak video. No more references. That's good. It's all about the get weak video now. And whether or not to use assert that we received the event for the right video element. C.report error. Picture and picture child received volume change for the wrong video. Let's break that up. Okay. And the other one was weak player content. Get weak player content. Returns a reference to the inner DOM window for the blank document. Returns a reference to the inner window of the blank about blank document that is cloning the originating video in the always on top player. Zool browser. DOM window. Or I think it's just window. The inner window, the about blank. It's just repeating myself. The inner window of the about blank player Zool browser, or null if that window has been closed. Weak player content. So this dot weak player content, we're going to do a find and replace from this dot weak player content to this dot get weak player content, and we're going to find and replace. So here's an example where like player content equals this dot get weak player content. If player content if not player content closed, Then we're going to say player content, add event listener. Okay. Oh, let's go back to what we were doing. Find and replace, find. Oh, no more. No one else is using it. Great. Just this closer. I feel good about this change. Let's take a look at the diff. Great. That all makes sense to me. Okay. Let us amend. And then let's run our tests. Test, toolkit, components, picture tests. Let's do it. And let's play some sounds while we wait for the tests to run. Let's see. Passed all our tests. Now let's do a quick manual test to make sure it, nothing jumps out at us. We'll go to YouTube. These are interesting. Might need to file those. There's a Shia LaBeouf answering some questions. We'll wait until this ad finishes clearing. Yeah, that behaves.
What's the charity? I got this theater company.
This is very similar to, I think, the Hot Ones interviews where it's like, do something spicy and then ask some questions. Very interesting. Anyway, that appears to work. Let's just check out Twitch real quick. What's going on Twitch? Let's bring this up. Can mute that. Put it back. Pull it out.
This is for the bundle. Follower.
Whoop.
Down. Yo, vegan lord. Thanks for the
Oh, that's interesting. Oh, you know what? It's because I clicked here. So for a while there, I mean, there is this bug where if you cannot click pause and replay on Twitch. But if one were to pause the Twitch video by its control, you can hit play. That's a known bug. It's all about the distance. Mute. Don't care. Advertisement. Oh, so clever. Keep the ad on screen even if I scroll away. Amazing. This is interesting. It's putting the can't get the picture-in-picture control here because they've overlaid it with their own extension for loot stuff. That's interesting. That's a perennial problem with Twitch and picture-in-picture. And there it is.
Okay, so we got one. You guys want to restart and do another one? We got time for...
Anyway, it's working the way I'd expect. Let us put this up for review. Okris asks, if you're playing with weak refs, shouldn't ref tracking be enabled and ref leaking check? Looks like you also have that media fatal error. Yes, this is unrelated. This is like within our media code in our decoder and demuxer. I think this error this is something that the media team is working on. So not like this bug pre-existed. It's something that the media team's looking at. And then Okris asks, shouldn't you be doing ref tracking enabled and ref leaking check? The answer is yes. We have what's called our leak checks that run whenever we run the tests with debug enabled. So we could do that if you'd like, but that's going to happen anyways whenever I push this to try or push it to autoland, where it'll run with our leak checking stuff enabled to ensure that we're not leaking. But if you'd like, let's check it out. Let's build with artifact debug. Let's pull down a debug artifact build. Oh, got a clobber. Mock build. And with this more or less wrapped, I don't think we're going to have time for this. But we can maybe start taking a look at it. I can start explaining this bug that I wanted to work on. And we'll see. Okris said, I saw it wasn't enabled when you ran tests. That's right. It's disabled whenever we run normal opt build tests. It's enabled whenever you run the tests in a debug build. So we can run that if you'd like. So I'm going to get a debug build, just downloading the various bits and pieces, and then we can run the tests with debug enabled and see if we're leaking. Because who knows, maybe we're leaking. So what is this? Consider gecko profiling to be run at the end of every normal test run and upload artifacts for every run. So this is something that a few of us in the performance group were talking about this morning, which was we have these benchmarks called the Talos tests that exercise various parts of the browser to make sure that they're performing, like the performance is sufficient. So it does timings of things like page load or like how long it takes to switch tabs, that sort of thing. And that's called the Talos suite. Talos runs with profiling enabled to do the same thing, but they output no numbers because their values are skewed by the profiling overhead. Instead, upload a zip file containing a profile of each execution of the test. These 10 profiles are often more confusing than useful, as we currently have no good way to compare them. And the engineers looking at these profiles tend to just randomly pick out one out of the 10 and ignore the others. What I would prefer, if it's possible, is that in the same job, we run the test 10 times to produce numbers, and an 11th time with the profiler enabled to upload a single profile. This would eliminate the difference between Talos with profiling and Talos without profiling, as all Talos runs would generate a profile. If we can move to something like this, I don't think profiling should be limited to Mozilla Central. All Talos runs on tried integration branches would have profiles. How feasible is this? Ideally, this would be looked at for Raptor and Talos. I like this idea a lot. I'm trying to think of what the simplest way to do it would be. Okay, our debug build is done. So let's quickly run the tests and make sure we're not leaking. So I'm thinking about the best way of doing this. Let me think for a second. I'll think out loud. That might be more interesting. So my first instinct was to modify it so that whenever we've run the tests any amount of times, we always loop the test one more time and then run it with profiling enabled. That was my first instinct. However, our test jobs, all of our automation runs using this infrastructure called Task Cluster, which is the Mozilla, I guess, job running tool. We used to use a thing called BuildBot, and we replaced it with our own homebrew thing called Task Cluster, which is a lot more powerful and scales better. And leak to 0, no leaks. No leaks, no leaks. Looks good. Leak check. No leaks detected. No leaks detected. Amazing. So, we're good to go. Let me push this patch up to my Fabricator. I'm feeling pretty good about it. And I can also close out, trying to be reduced. Submit. I think I closed all of the issues. Were there any inline issues? Hide done inlines. Cool. Done. That one's also done. Okay. So I don't believe there are any more not done inlines. Done, 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 done. Done, done, done. And so the new revision is up. So if I reload this page, revision updated. Here's our new function, get week over video. And yeah, I feel pretty good about this. Thanks for the review feedback, Mark, and that's why we review. It makes our code better. Okay, what was I talking about? I was talking about Task Cluster. So let me take a look. Let me show you something. TreeHerder and Task Cluster kind of work hand in hand. So this is TreeHerder. This is the tool that we use to look at the various jobs that are running in automation. And it's pretty cryptic. Like if you've ever seen this before, it's like, what is all of this information? What are these letters? What are these rows? Why the pluses? What does this mean? And it's one of the things that I find that people who are new hacking on Firefox and they push to one of our, like the try repositories, or they land, this is the tool that they use to like see the health of what they've pushed, but it doesn't make any sense. And that's because there's a lot of information. It's very dense. This is an information-packed page. It's very dense, and if you don't know what the symbols mean, it's not clear at all. It's the sort of thing that you kind of have to learn. So I can kind of briefly talk about it. All right. What we're looking at is a push on a particular repository. In this case, I'm looking at the try repository. And I've actually filtered it so we're only looking at try pushes where I am the author. I go here often just to look at the health of my own try pushes. And so each of these items, like this block that we're looking at is one push. Here's another push right here where no jobs were run for some reason. Here's another push. So each of these blocks where there's like a bunch of stuff on the right and like a date in the top left, that's a push. And a push might include multiple commits. You might have like 5 commits that you have a single push for, and you run a job on that push, not for one commit, but that push, which may include 1 or more commits. Okay, that's the first thing. Second thing, we've got some information here: the date of the push and who pushed it, and the commits that were in the push. And you can look at the individual like commits here. Like in this case, this was the original version of the patch that Mark reviewed. So that's, you can look at that revision, and this other revision here is something that gets put on top automatically whenever you push to try to tell infrastructure what jobs to run. And then on the right, this is probably the most interesting part, or the part that is most cryptic. On the right, it's telling you what happened, what jobs happened, what their status was, what platforms they were running for, etc. So on the left here, we're seeing what platform a particular job ran on. And on the right, these various symbols say what job ran, what kind of job. In this case, this symbol BA, if I click on it, will tell us a little bit about the job. This was a build on Linux 64. And it's green, so that's the other piece of information. Because it's green, that means it succeeded. And what does BA stand for? Why is this so cryptic? Well, unfortunately, it's the sort of thing that I think should probably be in the tooltip, but it's not. BA stands for artifact, or build artifact. So I did an artifact build on Linux 64 and one for Linux 64 debug, and on macOS opt and macOS debug, and some builds on Win32, Win32 debug, Win64, and Win64 debug. So all of these got artifact builds created for them, and those all occurred successfully. And then we have separate machines that do the building from the machines that do the testing. So these machines then did the testing. The M stands for Moki tests. There, the tooltip is actually working correctly, although you probably can't see it. It's really small font in the tooltip, but that tooltip says Moki tests. And if we unpack, the plus symbol means there's information that has been condensed, and if you click on it, it can unfold. So like +7 green means like there are 7 jobs in here that all succeeded, and if you want to unfold it, you can. Blue means that something went wrong. What was it? We retried it. Something went wrong with infrastructure, and it was automatically retried. So that's why these two went blue, and then it was retried here, and it went green. And sometimes that can occur if like some stuff hiccuped in infrastructure, because we've got machines in like Amazon Web Services and machines at Mozilla and machines here, there, and the other, and they're all talking to one another, and there's like a lot of room for error where things can go wrong. Like, I don't know, Amazon has a hiccup, or Google has a hiccup, or Mozilla has a hiccup, and like, whoop, error code, and then we automatically retry. If things go really, really wrong, like if the build fails, or there's like a really brutal crash, or whenever attempting to do the build itself, then these jobs will turn red. And I don't think I've got any reds recently. The one that's more common besides the green is orange. Orange means test failure. So in this case, the tests, there were some test failures in this try push. Now, one of the problems with automated testing, if you've ever written automated tests before, which you should, if you're writing software, you should write automated tests. It's good for you, it's good for your software, and it's good for your users. If you have a sufficiently large test suite, and if you have a sufficiently varied amount of hardware that those tests are running on with a sufficiently different set of conditions and environments, you will invariably run into this problem where tests will fail intermittently. And that's due to timing issues, or, well, it's almost always related to timing issues, like racy tests effectively, or flaky tests. We, on Mozilla Central, like if we're looking at the Mozilla Central repository or the Autoland repository, we have this bank of known flaky tests or known intermittent failures, and we automatically like star them. So that means like putting an asterisk beside all of these and making them kind of like a weaker orange to say like the test failure that occurred for this job is a known intermittent test failure. We re-triggered the test and it went green, so don't worry about it. We don't do that on the try pushes. So it's up to us to like kind of do it ourselves if we want to. And in this case, this tool down here helps us identify whether or not we are dealing with an intermittent test failure. And in this case, it looks like yes. This is the actual error message. It was test unexpected fail. in this URL bar test, and here's the error message. This dummy page.html was found in autocomplete and was not expected. And then there is a known intermittent that exactly matches that error message, although it matches tab match 7. It's not exactly a match, but it's sufficiently similar that I'm reasonably certain that this is the same test failure. And so one could star this. And I'll bet you if we go through each one of these, there are known intermittents, like this one. Last task finished, application timed out after 370. Exceeded max 20 bug suggestions, most of which are likely false positives. Watchdog. This one I've seen before. Oh, and these are also fission failures, which fission is what's called a tier 2 suite of tests right now. So even if they fail, my team is not charged with or currently there's another set of people who are looking at tier 2 failures. So I can actually hide all the tier 2 failures. So we really only care about the tier 1 failures. And for some reason that's not hidden. I guess fission on Linux 64 is now tier 1. Huh. But I've seen this failure before, and this is likely infrastructure. Some information is being hidden from us automatically, but we can take a quick peek. We'll open up the log test. Let me pop up the font. Test. Unexpected fail. There was a timeout. It looks like we hit a crash. Shutdown took too long. We were frozen on shutting down. Received observer notification. So this is a shutdown hang. And so we crashed automatically. And I'm reasonably certain this will happen periodically. A crash report is generated. And this is not a thing we need to worry about, or at least not for this particular patch. For this one, what is this one? Is this an assertion failure? What's this one? Bad access Moz Alec when attempting to. We aborted because why? Thread 5 crashed when attempting to allocate. Because we failed an assertion. Assertion failure. P threads. Yeah, here we go. P threads. So that's this known intermittent. Some questions in IRS or in the Twitch chat. Where you have bug numbers prior to the blue line, is that done automatically by TreeHerder or question mark for the known failures? So TreeHerder looks for bugs that have the keyword intermittent failure, and it also looks at the signature of the bug, like the bug summary. Pretty sure those are the two things that it looks at. The bug summary and the keyword for intermittent failure. And it will scan for bugs that have similar names. And for some reason, it's not finding 1415093 for this one, but that's what that one is. So I should probably star this one. So let me classification, add a related bug, boop, just in case people are curious. Intermittent, say, please classify this failure. Classification, intermittent. Oh, there, is that? There we go. Okay. And that's what a starred orange looks like. Over here, let's get rid of the pin board. Yeah, this is a very much this intermittent failure, so we can pin that one. And then, wow, with the font so big, these kind of get in the way, don't they? And this one down here should have no expect. Yeah, that's very much this one. Okay. Anyways, the reason I bring up task cluster and TreeHerder, I'm getting distracted or like starring these oranges on this try push. But what I really wanted to talk about was Talos pushes. So Talos is another job that will run in task cluster and be visible here in TreeHerder. So this is an example of a whole bunch of Talos tests. Each one of these letters represents a different suite of tests. In this case, C stands for, I think, the Chrome Z tests. D stands for Dromeo. DAMP is our DevTools tests. They're like really cryptic names. Really, really cryptic. No doubt about it. But what I'm thinking is that for each one of these, like if any one of these runs at least once, we automatically queue up another job that's like the name of the job that also does profiling. That's what I'm thinking. So if you run C one or more times, then there will also be like a C-profile or something to get a profile. Now, I don't exactly know how to do that, but I'm reasonably certain that this is possible. The way that Task Cluster works, it has a very complex and powerful like dependency tree like infrastructure that allows this sort of thing to occur. I'm trying to think if there's an example of something that already exists that we can reuse. Like for example, when you run a PGO build, we will automatically run the inster job and the run job, no matter how many builds you actually create. So for some reason we built 10 here, but we only ran the instrumentation and the run job once. So I wonder if we could use that as like an inspiration. So let's see if we can find the code for this. All of the code actually lives inside of the repository that Task Cluster is running on. Like that means that if you push changes to Mozilla Central, the behavior of the jobs that run reflect what's being operated on. Like the instructions are in the repository that's being operated on as opposed to in a separate repository. And that's a really nice model actually. So we can find, let's look for BPGO in the repository. See if we can find that symbol somewhere. So yeah, there are all these like YML files that describe how things work. Like on Windows, in our Task Cluster CI build windows.yml, we've got this thing. We're describing like a shippable opt build. On TreeHerder, it has this symbol. It's a tier 1 job. And I'm curious about the dependencies. Shipping phase, fetches, like where are the inster? Like does it make reference to something called inster? It does not. But I want it to. Let me see if I can find this like symbol inster. No? Okay, how about inster in .yml? Aha. Symbol. Job defaults. There it is. When running instrumented build, you do this. And then these are the jobs to run an instrumented build. Was that where I just was in kind.yml? No, I was in something called like windows.yml. What's the difference? kind.yml, and this also has something called win32 shippable opt. Jobs. So what's the difference? Here, let me open up a new tab. We'll go back. On Windows, we have this thing called job defaults use shippable opt. Is this the same thing? They look like when 32 shippable PGO instrumented, opt shippable. What's the difference? Stage platform. Type is shippable. What does that mean? Kind. Jobs. Like, what does kind.yml used for? Instrumented build. Generate profile. Kinds. Task kinds. This section lists and documents the available task kinds. Builds are tasks that produce an installer. Put sign an artifact build, a hazard, L10N, source test, code review, upload symbols, valid grind, search, Fox, stack, analysis, SpiderMonkey, a test, Docker image, Balrog, beat mover. So presumably Talos is one of these like test kinds. Do we actual metrics, web render, fetch jobs. So I'm pretty sure that the job is like a test job. Talos, yeah. So these are the job defaults, and then one of the things you can ask from Talos is like a profiling Talos test. How do you do that? Task cluster profile. Not these. These are talking about like profiling. Profile is one of those words that's super overloaded in the code base. Profile, you can have user profile for like, that's almost like an account in Firefox where it's like your database of bookmarks and history and all of your history and whatnot. That's one known for. That's one type of profile. Then there's like a performance profile that's gathered whenever you're using like a profiling tool to do performance analysis. Then there's like profiling for a PGO build, so creating a execution profile to figure out how best to reorganize a binary to be more efficient. And all of these different profiles are what we're looking at here. I'm looking for the performance one. I'm trying to find it. Is there anything in here about Talos, for example? Aha! Transforms. Task graph transforms tests.py. That's kind of related. Talos, Raptor, extra options, Gecko profile. Profile. Oh, it's an action. What's the difference between an action and a kind? a decision. Try task config schema. That adds us the ability to like deal with gecko profile as like an argument to mock try. Okay. And then there's the transforms, and then in raptor.yml, try option syntax, tests, mouse harness, gecko profile, and then there's this thing, this action. Take the label of the current task, trigger the task with that label on previous pushes in the same project while adding the gecko profile command arg. So who uses this action? Gecko profile action. Because that sounds like exactly what we want. No, never heard of it. The name is gecko profile. Ooh, let's take a look at the revision where it was added. This capability. So, and then there's a for test, set test type for test type. Mock test, ref test, house, or raptor. Test default set tags. Okay. How does this work? How does this work? I believe something like this might be a retriggered talus with parameters. What? Multi-test retrigger. Doesn't exist. Aha, retrigger multi-test is what it was named to. Test retrigger action. So it's almost like we want to run this type of action. As soon as we've run, if we run it once, we automatically re-trigger with this type of action. With the, there's going to be like gecko profile in here. Except there aren't. It's like we dynamically accept it as part of like the, it's not explicitly called out here, but it's one of the things that I think just gets like brought along. Excuse me. Clearly I'm out of my depth is what I'm realizing here. I need to talk to someone who knows how the task graph works, because I think that's what we need to do. There's like a dependency tree that sort of figures out what jobs need to run in order to do a certain thing. And I want to modify the logic of our dependency tree such that if any Talos test runs at least once, we queue up another job that runs that same Talos suite with profiling enabled. That's what I want to do. So I need to talk to someone about that from like the task graph team or the TreeHerder team, or the task cluster team really, to figure out how to express that in the code, because I don't know how. All right. See if there's anything left to do. Anything left to do here? Just double checking. Aren't you worried that adding a profile will cause issues? Not really, because it's not like profiling while running the performance test, like as a replacement for the original runs. It's do the original runs and do the actual, like, the measurement, take the benchmarks, and then create yet another job that does the profiling and emits the profiles at the end, so that we can then analyze those profiles. So it doesn't affect the original measurements. It's an additional job on top of it. To answer your question, Smurfd. So no, I am not worried. To answer your question, hopefully that answers your question. I think I'm going to call it here. I've only got 2 minutes or so left. I got to give up this room, and we were able to get some feedback here, and put up a new patch, and started to think through this bug, but didn't really write any code. But I realize now that I'm out of my depth, and I need to talk to someone from the task cluster team. And we've, thanks to Ocris, there is an idea here on ways we can suppress some error messages that show up whenever you're shutting down a tab. Cool. So I'm going to call it here. Hey, thank you so much for watching episode 196 of The Joy of Coding. It's been so lovely to have you here. I'm sorry if you were hoping to catch the YouTube live stream and you couldn't. That happens sometimes, but I've asked for logs from the people who run the streamer, or the stream infrastructure, to see if we can figure out what is going on, because sometimes it works, sometimes it doesn't, and that's just the way it is. Just the way it is. Doop-a-doo, doop-a-doo, doop-a-doo.
I can't do my work. Why just spill your beans?
And with that, I'll call it. So thanks again. Let me just switch to my camera and play myself out. Take care. I'll see you next week. Bye-bye.
The joy of coding.
See ya.